Welcome to the second week of lecture on aspect of chemistry. In this lecture, this is the first step in beginning the analysis that beyond the level of doubt that will enable you to understand everything that we have put together under the hierarchy of chemistry. You remember in the hierarchy of chemistry, we discussed the subatomic particle, electron, proton, neutron, that come together to form a whole structural aspect of smallest unit of things in universe that is responsible for chemical reaction, which is atom. When we begin from this level, we progress up to the last level until we reach the last aspect of chemistry, which we have to deal with bigger submolecular entity under the fatty acid, carbohydrate, and sort of thing. But we need to move in steps so that you will understand the basic principle behind everything in nature. And I'm telling you, this is the best thing you can ever have. I implore you to please follow the steps that will be given to you. Follow the principle and apply it to solve questions that you have. I implore you that you should be able to get your past question at hand by now, because you will be using the principle to solve the problem that you'll be having in your past question. If you have any doubt, you have any problem, please do not hesitate to contact us. As soon as we'll soon include your forum on the system. I'm telling you that this is the first aspect of second week of chemistry. We will begin discovery of atom as a whole structure entity. That is very important to us. Now, the first thing that we're going to start with is what you see on the slide, which is subatomic particle. We want to start discussing subatomic particles. So, if you look at if you look at what you see on the screen, you will see atom. Under the atom, we have electron, we have proton, we have neutron. Under electron, we have energy level. Under energy level, we have something we call orbit. We are going to understand this thing in step as we're going through, because I will walk you through the history of how atomic structure is discovered. Now, what is atomic particles? What are the subatomic particles? If you could look at the screen, it is telling you that subatomic particle, what you have here is saying subatomic particles are components of atom. To understand atom, we must understand the nature of these particles, of these subatomic particles, which are electrons, protons, neutrons. Well, now, protons and neutrons form the nucleus. That's the reason we say that the nuclei, nuclei is the plural of nucleus. Are you getting me? So that's the reason we say nuclei of an atom, which is the atomic mass. You understand that atomic mass, it is the sum of proton plus neutron, which is the center of the atom. The sum of the proton, it is the atomic number. You remember that we mentioned this in the last class, which is the position of atom on periodic table. Please, I want you to know this relationship. I want you to follow it very clearly so that you won't do any mistake. That is to say, atomic number, it is the number of proton, and it is also the position of atom on periodic table. So if they say that an atom in position 20, you should know that that atom has proton number of 20, and that atom should be calcium. Now, the electron revolutionized around the nucleus. You know that electrons spin around the nucleus and spin on its axis, yes. Electron revolutionized around the nucleus as well as spin on its axis. That is to say, if I have an atom like this, there is something called electron that is moving around it, revolutionized, and that electron itself is also rotating on its own axis. That is to say, there are two possible rotational motion for electron, revolution and electron spinning. Electron can spin clockwise and it can spin anti-clockwise. That's the reason why we say that it has positive spin and negative spin. That is, it can spin up and it can spin down It can spin down and it can spin up. So spin down is negative, spin up is positive. It doesn't mean that vertical and it doesn't mean vertical motion. What we are trying to represent here, it is the spinning in either clockwise direction or anti-clockwise direction. That is what we are trying to say when we are talking about up spin and down spin, which is clockwise and anti-clockwise spinning. And I believe you know the meaning of spinning now. I have explained this structure that we have here, and let us begin to look more into what we have in atomic history. So, discovery of electron. This man is called Joseph John Thomson. That's the reason why we call him J.J. Thomson. So, this is the man that show us what electron is. It is the one that discovered electron. And I will walk you through the process by which he discovered this. I want you to follow the history line, and I want you to follow what is the line of history so that you won't do any mistake. Look up. During 1880s and 90s, scientists searched cathode ray. They searched cathode rays for the carrier of electrical property in matter. I will explain this. This work culminated in discovery by what? By English physicist. The man is Britain, J.J. Thomson, of electron in 1897. The existence of this electron showed that 2,000 years old conception of atom as homogeneous particle was wrong. Are you getting me now? That is, before the 2,000 years ago, before J.J. Thomson discovered atom, they are saying atom as homogeneous particle. So when J.J. Thomson now discovered atom, he now discovered that it is not an homogeneous particle. That is to say, it is a whole big entity of nature that also contains some other entities. So it proved the homogeneous particle of nature wrong, and that in fact the atom was a complex structure. It discovered that electron is cathode ray. Now, what I want to tell you here, this is what we call cathode tube. This is called cathode tube. There are many scientists who have worked in the line of history to build something. It is not J.J. Thomson that built this glass. He just used this glass. There is a man that built this cathode tube, and there is a man that discovered cathode ray. There is one man that before J.J. Thomson now discovered electron. Are you getting me? There is a man called William Crook. William Crook, it is the one that discovered cathode ray, that this cathode, there is a particle in an atom that carries charge, and it's called cathode ray. And in trying to explain cathode ray, he doesn't know the nature of cathode ray. He just knows that it's cathode ray, but he doesn't know the nature. He doesn't know what is inside the cathode ray. So it is like somebody discovered that, this thing is Gary, and somebody said that, if it is Gary or this thing is water, that is water. What's inside the water? So William Crook discovered cathode ray, but he doesn't know what is inside cathode ray. What is the nature of this cathode ray? So this is what J.J. Thomson did. He discovered cathode ray, that it is a stream of fast-moving electrons, and this is the tools that he used. Let me try to explain these tools to you so that you will understand what these tools is actually saying. Now, these tools here, there is a particular metal here. This metal is called cathode. This metal is called cathode, and it is connected with a group of anode metal, and it is connected with a group of anode metal. So this is the anode, which is positive. This is cathode, which is negative. So these are the things that they connect together to enable electricity enter this system. So when they connect it together, immediately what happens? This one will glow. It will glow. It will glow, and it will become red like a structure. Imagine when you are using your hot plate to cook. When you put your hot plate in fire, what will happen? The whole string of metal will glow and turn red. And that is what happened in this particular analogy. So what is happening here is that when this thing glow red, it will begin to emit electron. Although this thing you may not see it with your own eyes. Scientists do not see it with their own eyes too. Don't worry, you will see the video of how people view electron. You will see that it is a greenish color and it is homogeneous for all elements that was used. But they use hydrogen because it's very light, and they test other elements and they notice that they observe the same nature, that electron is the same throughout the element, no matter the atomic mass of that element. So the electron will move faster and to be focused by this string. This string, there is a tiny hole so that very tiny stream of electron will propagate through here. And this is electric field. You can see that it's a big coil of wire. And during this coil of wire, this guy noted that yes, when they connect this wire together, when they activate it, they activate both electric and magnetic field, and they notice that this electron bend towards one direction. But when they switch it off, what happens? The electron travel in a straight line and get to the surface of the screen inside here. This surface is a zinc coated surface, and when the beam of electron hits this surface, they see some particular radiation that come out of the surface. So this is the whole structural architecture of cathode ray tube used by J.J. Thomson. So this is the clear analogous and full label structure of that cathode ray tube. You may note it down and try to draw it and see the label, understand each part of the label and what they are doing. Because if they label it for you in the exam, you must be able to identify each structure. And as I've told you, this is the cathode. You remember in that structure, the two rings here, you can see they are the anode that's connected together to this to form to introduce electric field into this thing. It will glow red and electron will migrate. You may not be able to see it, but in nature, because of the fact that this thing undergo kind of radiation, you'll be able to see it. Now, I want you to understand some things so that you will not be confused with the nature by which electron is discovered. Now, let me tell you one thing. When they activate this thing, there is a particular gas they use here. This gas, they can use any atomic gas. But the one that they use during the time of our guy is hydrogen gas. But they have used other gases. Are you getting me now? So they used hydrogen gas, and this gas occupied everything. It was inside this tube. But this gas cannot be so heavy. They use very small amount of this gas. So there is reason why they say that the gas is at very what? Low pressure. The gas is at very low pressure. Sorry, it's at very low pressure. The gas is at low pressure, and that pressure is about 0.01. It's about 0.001 atmosphere. But here, they introduce high voltage between anode and cathode so that large amount of electric field can flow within the gas. The voltage is about 10 raised to power 5 volts. The voltage is about 10 raised to power 5 volts. Now, when they introduce the voltage here, the voltage that is very high will force electron to migrate out in a straight line, and tiny beam of electron will get here. When it gets to this place, it will meet all atomic gases of hydrogen gas that is here. It will meet them. And when this electron meets them, what it will do is that it will collide with the atom of this particular hydrogen. And when this electron collides with this electron, it will knock out the electrons on the hydrogen gas, and many electrons will be flowing in this tube. During that process, some atoms will undergo excitation and realization, and that's what will cause this entire place to glow with light, and the light is greenish color light. You can now see what I'm talking about here, that there is electron that is flowing from the cathode tube, and there is electron that is knocked out from the gas at low pressure in this place. So therefore, this electron that is knocked out was the one that is actually what we call a cathode ray. And that cathode ray, it is the fast stream of moving electron. It is a moving electron that is moving very fast. So cathode ray, it is a stream of fast moving electron, and it carries negative charge. So this one is electric field is to test maybe the electron is carrying charge, and if it is carrying charge, it will deflect it towards the positive charge because electron is negative. You know that unlike charge attract and like charge repel according to the universal law of magnetic field and the magnetic attraction. So what we're saying here is that it will move towards the positive charge and move away from negative charge. So therefore, during the movement, it will collide with the zinc coated surface layer, and it will cause the scintillation. What we mean by scintillation is fluorescence. So it will cause this place to glow. So don't worry about the scintillation. So you will still understand what scintillation is all about, and I will introduce you to what we call a device called ginger molar scintillation counter, because it's very, very important in discovery of some particles that we are talking about. So this is phosphorescence coating. Phosphorescence coating means that it is a surface that will glow with light when electron collide with the surface. So this is extensional diagram that also show the work of J.J. Thomson. You can pause the video to look at different aspects and see what they are doing. So now this one here, it is not the actual interpretation of J.J. Thomson. It is advanced aspect of J.J. Thomson. This is the cathode tube. This cathode tube, it is now the tube that we are using in our television today. Are you getting me now? So for those of you that have this kind of television at home, for those of you that have this kind of television at home, you can have a red unit, is somebody that specializes in repairing television, to show you the television tube. And every aspect of that tube, you will see that there is electron gun that fire electron into the tube. Electron particles again, you will see them as a continuous color that will show on your screen. So this is the advanced layer of J.J. Thomson device that is used, which is the cathode tube that is discovered by William Crook. So at this point in time, you are seeing introduction to what that J.J. Thomson used in discovering his own electron, and we have explained the overall structure of that tube. So therefore, we continue in the next lecture to discuss this discovery of electron. Thank you for listening. A B P.